The earliest instrumental records of Earth's climate, measured with thermometers and other tools, begin in the 1850s. To go back even further in time, scientists study air bubbles trapped in ice cores, which extends the window to less than 1 million years. But to examine Earth's history over tens to hundreds of millions of years, scientists examine the chemical and biological signatures of deep-sea sediment archives. The study, published in Nature Geoscience by Richard Zeebe et al., examines changes in Earth's temperature and atmospheric carbon dioxide, CO2, since the end of the dinosaur era. Their findings show that humans are releasing carbon about 10 times faster than during any event in the past 66 million years. A research team has developed a new method and has been able to date a major past climate event, the Paleocene-Eocene Thermal Maximum, or PETM, 56 million years ago. The PETM was, as far as we know, the most carbon-producing event of the past 66 million years. Zeebe said. By analyzing the PETM, they calculated how fast carbon was being released, how fast the Earth's surface was warming, and constrained the timescale for when it started, to at least 4,000 years. The rate of carbon release during the PETM was determined to be much slower than the current input of carbon into the atmosphere from human activity. Scientists estimated that the maximum sustained rate of carbon release during the PETM must have been less than 4 billion metric tons of CO2 per year, about 1/10 of the current rate. Because the rate of carbon dioxide release is unprecedented for such a long period in Earth's history, it also means that we have essentially entered a state of no analogy. This poses a major challenge for forecasting future climate change because we don't have a good comparison to the past, Zeebe said. While large climate changes in the past may have been relatively mild, there are no guarantees for the future. The climate system is nonlinear, meaning that its response to a forcing agent, such as our CO2 emissions, is a complex process involving a whole set of components. If you kick the system really hard, it will usually respond differently than if you push it slowly but steadily, Zeebe said. Furthermore, it is very likely that future ecosystem disruptions will outpace the relatively limited extinctions observed in the PETM. By studying one of the most dramatic episodes of global change since the end of the dinosaur era, scientists are showing that we are currently in uncharted territory when it comes to the rate at which carbon is released into the atmosphere and oceans. Scientists like Zeebe are also studying the PETM to better understand long-term changes in Earth's future climate. Much of the current climate debate is focused on this century, but the PETM shows that the consequences of our massive burning of fossil fuels will have a much longer tail. Everyone is focused on what happens by 2100. But that's just 2 generations from now. It's like, if the world ends in 2100, it'll probably be okay. Zeebe said. But it's pretty clear that there's going to be much bigger changes in the long term. Zeebe and his colleagues are continuing to work on the PETM to investigate other aspects of the event, for example, determining how severe ocean acidification was during the PETM and what effect it had on calcareous organisms in the ocean. That could provide insight into what to expect in the future as Earth's climate continues to warm and oceans continue to acidify.